So the final thing that we're going to do in this set of notes, we've already looked at one of these kind of weird looking little functions but the last time we looked at them, we were given the function and then we were told what had been done to the function and asked to find the graph. In these problems, we're given a basic function, and then by looking and comparing, we're asked to determine what transformations happened and what is the new equation in terms of this f of x. So, just like we did before, we're going to keep it in terms of comparing the x's and comparing the y's. First of all, we're going to look at the zeros. Now here, notice the zeros here and here, and then we've got those zeros that are there and there. Because the zeros have not moved up or down, because the function is still on that x-axis, we know that no vertical translation has occurred. So this thing has not been moved up or down at all. The stretch, right, hasn't been stretched this way or this way. What's going on there? So we see that the largest number that happens is 4. The smallest is 0. All right? So the difference between 4 and 0, when we look here, we're going from -4 to 0. So there's been no stretch or compression vertically. So let's go down here real quick. All right, so we're looking at R, S, and T, right? And actually, all right, so we're looking for that R, S, and T. We know that the translation, right, we have no left and right because the 0 is still at -3. It is still at +3, so it is not up or down because the zeros are still the zeros. So we have no translation. As far as stretch goes, biggest value is 4, smallest value is 0. There's a difference of 4. Smallest value is 0, biggest value is 4. So the range is the same. The range values have the same spread. So there is no vertical stretch. We're going from -3 to 7. We're going from -3 to 7. So we have no stretches in any direction. And then our reflection happens. We had 3. We've now got -3. We had 4. We've now got -4. So there is a vertical reflection. So in the end, the only thing that happened to transform this into this is that vertical reflection. So our new g of x function is just going to be negative f of x. Nothing at all happened to the x. The only transformation that we had was that vertical reflection. Let's do that again. So now we're looking here. What's different? What's the same? So -3 is the 0 here. -3 is still the 0. 3 is the 0. 3 is still the 0. 7 is the end value. 7 is still the end value. So there's nothing horizontally has happened at all with this thing. Our zeros are still the same, and the spread of values, as far as is it more or less spread out, is the same. So we have nothing occurring here, right? The tail is on the right side still, so it hasn't been flipped over horizontally. Nothing occurred horizontally. Now, what about vertically? So our 0 points tell us about shifting up and down. Zeros are still at the same place, so it hasn't been moved up or down. Or those zeros, those points would be at a different place. The smallest value is 0. The largest value is 8. Smallest value is 0. Largest value is 4. Here we got up to 3. Here we get up to 6. So it looks like all we've got is a vertical stretch factor 2. Because all the values that we've got are twice what they were. So g of x equals 2 f of x. All right, this next comparison, all right, this looks a little bit different. We've got a lot. I think we've got a lot more going on here. So let's figure out what we've got. So first of all, right off the bat, we talk about our reflection. I think it's pretty obvious, right? This one is upside down. So we have vertical reflection. Now, this point, which corresponds to that point, is still at the same x value. This point is still at the same x value. This is still at the same x value. So there is no stretch or compression horizontally. But vertically, now that's different because the minimum value now, right, is 1 to 3 as opposed to going from 0 to 4. So the entire range went from 4 spread down to 2. So that's half, right? So it's been vertically reflected. It has also been vertically shrink by 1/2 because the difference from top to bottom is half of what it used to be. Now, where are these zeros located? All right, where are these points that used to be on the x-axis located? Well, they're still in the same place horizontally, so we don't have to worry about horizontal movement, but it looks like they've been shifted up 3. So up 3. So taking all that into account, our new g of x function is going to be negative, because it's flipped over, 1/2 f of x. Did not do anything to that inside x because horizontally we're still going from the same smallest value to largest value. So there's absolutely no shift left or right. And the spread is still the same. But then we have also moved up 3, so we're going to add 3 onto the end of that. Lastly, we have this one, and we'll just do this one over here on the side. So comparing those two. As has been the case every time, -3 up to 7. No horizontal differencing at all. No shift, no stretch, no compression, no nothing. So that's okay. It definitely does reflect. Oops, let me come down a little bit. It definitely has reflect vertically because it's going down instead of up. Stretching. We already said horizontally it's going from -3 to 7, just like it has in every other problem. So there is no horizontal stretch. Vertically, we're going from -11 to -3. So that's a difference of 8, where here we had a difference of 4. So vertical stretch, factor 2. And then we also moved it down 3. So our new function would be g of x equals reflect vertically by a factor of 2, f of x minus 3. All right.